Scooby-Doo, looking for you. Scooby-Doo, where are you? All the stars are here, waiting for you. Couldn't have a show without you.
For the following set of videos, we want to continue our discussion about functions and how to analyze functions. And so we have a new definition, increasing, and then another for decreasing, and finally a definition for constant. And I have a very formal definition here for you. You'll see in blue for increasing, and then I have an easier way to think about it. But a graph is increasing if for each x2 greater than x1, then f of x2 is greater than f of x1. Okay, so I want to break this down and explain what it means, and then the second sentence we'll talk about that from looking at our graph of what it means. And so over to the right, I want to set up an xy axis, because that's what we're talking about, is graphing. Okay, and it says if x2 is bigger than x1. So along the x-axis down here, I want to list just two random x values, so that x2 is a bigger number than x1. And you see that would work. Now I didn't have to put them on the right side positive. I could put one positive, one negative, or both negative. I'm just keeping it simple. So x2 is definitely bigger than x1. And then it says, then, if the function's increasing, f of x2 is also bigger than f of x1. Now remember, f of x, those are y values. So the y value at x2 is bigger than the y value at x1. So this is another way of saying that. So I go over here and draw that. The y value at x2 is bigger than the y value at x1. And that, you could connect the dots as a straight line, or it could even be a curve, but that's what we have going on. And this, when you're looking at this, this is an increasing graph. Now notice what I said below. It says another way to think about this is the graph is rising from left to right. And that may be a far easier way to think about what I'm saying here. So if you'll notice, you'll look at this graph from left to right, the graph is going up. And so that's what it means to be increasing. On the other hand, decreasing, and I'll draw a graph to represent that. Notice once again it says for each x2 bigger than x1. So along the x-axis I need to draw an x1 and an x2 so that x2 is bigger than x1. Exactly the same setup we had for increasing. But here's the difference. F of x2 is the same as saying the y value at x2, and f of x1 is the same as saying the y value for x1, but it's saying the y2 or f of x2 is smaller than f of x1. So the y value at x2 is smaller than the y value at x1. And again, I can connect the dots. Okay, it could be a straight line, could be a bit of a curve, but what I want you to really notice here is the graph is falling from left to right. So if you read this like a book, the graph is going down, falling from left to right. Okay, and then the third option, and a graph must be one of these three things over any particular interval. The third option is a graph is constant. So I want to draw an XY axis to discuss this. It says the graph is constant if the graph is neither increasing or decreasing. Okay, so it's not doing either one of these things. Another way to think about it is you could say if x2 is bigger than x1, then f of x2 is equal to f of x1, because that's the only other option, right? If you got the greater than for the increasing, the less than for the decreasing, then equals is the only other option. If we were to graph that, then here's x1 and here's x2, just like before, but f of x2 is equal to f of x1. And that's not only true for these endpoints, but every point in between. And that's what's going on with all these definitions. Now, essentially what this really means is the graph is horizontal, and if you look at this graph, that's horizontal. So that's what constant means. So increasing means it's rising from left to right, decreasing means it's falling from left to right, and then constant means it's completely horizontal, no incline whatsoever. Okay? So for our problem here, what I want to do is find intervals of increasing, decreasing, and constant for the given graph. And I asked a few more things too, just for practice. So the first thing I'm actually asking for is, what is the domain? Remember, domain is x values, and you're looking on, well, from left to right, what x values give you this graph. So that's the best way to ask that question to yourself. From left to right, what x values create this graph? One thing I'm looking for is, there are any holes in the graph, and they're not. So we're fully covered from end to end. And the left end, notice the arrow means it goes on forever. So we're talking negative infinity to the right. Now it actually stops over here at, you check your scale, that's 5, 6, 7, 8. Ooh, is it 5, 6, 7, 8, 9? I think 10 is after that. See, 1, 2, 3, 4, 5. Yeah, our scale is okay. This negative 10 is actually right here. It's a little deceiving, and this positive 10 is right here, which, all that to say, this is 6. Now it goes all the way to 6. My next question to you is, does it include the 6? Well, no, there's an open circle there. I had to manually put that in myself because Desmos, the algebra system that I use to create my graphs, doesn't put these open circles on there, and so I have to put them in myself. But negative infinity to 6 is the domain. Now range, if you'll recall, is low to high. These are y values. The lowest y value on my graph is down here at -4. Now I'm going to put a bracket around -4 because that point is included. There's no open circle there. It literally includes the y value -4. How high does it go? Looks like it goes up to 5 for that horizontal line right there, and doesn't go any further. So that 5 is included. Okay, now we're addressing the question that's new to this section. Intervals of increasing. Remember, what that means is the graph is rising from left to right. And so what I need to do is, I need to look on my graph, and I'm going to write it right on top of the graph. Notice right here at, down below at this point right here, and this point is 0, -4, the graph begins to rise up. Now it rises as a curve and then turns into rising as a straight line, but it is rising that entire time. It doesn't matter that it's a different form that it's rising in, okay? Now this point right here, oh, forgive me, okay? This point right here is the point, the open circle here is at 6, 4. So I'm going to label that 6, 4. So my graph is increasing over this entire interval right here, okay? Now we'll write that down in just a minute in interval notation, but right now I want you to see that it's increasing. Now if you'll look at this part right here to the far left on your graph, that's horizontal, right? So that means it's constant. So let's write that down. This area is constant, okay? All the way from way out here to this point right here. And let's label that point. So that's 1, 2, -3, 5. So I think it helps to have these points labeled as you go through and do this, which means this part, this piece in the middle, that is decreasing. And I'm going to write it again right on top of the graph. This is decreasing. Now, why right on top of the graph? One reason, so you can see it. Another reason, if you're doing this in the homework, or more importantly on a test, you may want to do that for me, just in case you answer the question wrong and writing your answer in interval notation, but I see you know where you're talking about. That way I can assign some partial credit to your work because you have the right idea, you just didn't translate that information into interval notation properly. So increasing, where does the graph begin increasing? Well, first thing you would say is 0, -4. But when you answer all of these questions, when you answer increasing, decreasing, and constant, you use x values only, okay? So for the highlighted, you only use x values, okay? And that's for, again, increasing, decreasing, and constant. Range, you used y values, but domain, you used x values. For increasing, decreasing, constant, x values only. So let's go back and see if we can pull that off. Okay, so the x value is where it increases. Well, notice it started at 0. The -4 doesn't matter. I'm going from 0 to 6. Okay. Now, here's another thing. The 0 is included and the 6 is not included. So if you put bracket 0 to 6 parentheses, I'm okay with it. But that's how your current book would do it. On the other hand, if we go back to that formal definition of increasing, so I'm going to flip the page on you real quick and look at the definition of increasing. It says for each x2 greater than x1, f of x2 is greater than f of x1. That can't apply to a single point. That is talking about one point compared to another point. Well, if I go back and look over here at this point 0, that's not bigger than another point. In other words, what I'm trying to say is the end point all by itself, the end, can't be increasing or decreasing. As a matter of fact, how do you distinguish if you include this point on increasing, you would also have to include it on decreasing. Well, you can't be increasing and decreasing at the same time. So my argument is always put parentheses around increasing, decreasing, constant. Then you might ask me, well, what if I decided to include it? And then I would say that's okay because that's what your book does. But, and the 6 we couldn't include because it's not even defined. But again, I always use parentheses, increasing, decreasing, constant because of the nature of the definition. Now we're decreasing. Remember, x values only. So I begin decreasing at -3 and I end decreasing at 0. So that's -3 to 0. Now I want you to always check your intervals. Your intervals always, 100% of the time, should be smallest number on the left, largest number on the right. If it's not, that means you're either thinking about something wrong or you're writing it backwards. Okay? And then intervals of constant. So again, x values. The x value far to the left is -infinity, again, parentheses, all the way the x value to the right where it finishes being constant is -3. Again, notice smallest to largest. Okay? Now, for 2 questions you already know how to do, okay? F of 0, okay? So f of 0, when I go and look at 0, remember that's an x value. So if x equals 0, I'm asking you what is the y value. So if I go to x is 0, that's right here, the y value is -4. So f of 0 is equal to -4. I want to do the same thing for -3. So first of all, I go to my graph and I find x is -3. 1, 2, 3. That's right here. Okay. Now I don't stay there. I go meet my graph. So that takes me to this point that I'm filling in dark green, and the y value right there is 5. We actually already had that one labeled. Okay, it's time for a new definition. We've got relative maximum and relative minimum that we need to define. It says a relative maximum is a y value, you could also call it f of a, so f of a is a y value, of the function f if there exists an open interval containing a such that f of a is greater than f of x for every x that's not equal to a. Okay, again, I know that sounds like another rigorous definition, so let's draw a picture. All right, now it says an open interval. Okay, now what that means is it doesn't mean your entire graph. It just means a piece of your graph. All right, so a piece of your graph, and let me just draw a graph for you. All right, we have a piece that says an open interval such that f of a, that's a y value, is bigger than f of x for all of those in a certain area. Okay, now I'm going to show you that this is what I mean right there, okay? Because if you look at this little interval, let's just look between this x value and this x value, okay? Ignore the rest of the graph. So only look between here and here on the graph, okay? What I'm trying to say is that this f of a right here, that would be your f of a, your y value there, which is that high, is bigger than f of x for all the other green. Okay, so this y value is higher than all the others. Now, what I like to tell you, just to oversimplify it a little bit, is that it's a mountain. Okay, I'm a hiker, so a way to explain that is a relative maximum is a hill or a mountain that you can hike up and over the other side. Okay, if you can't hike up and then go back over down on the other side, it is not a relative maximum. But if you can hike up to the top and back to the other side, then it is a relative maximum. Okay, now let's look at a relative minimum. Is a y value f of a of the function f if there exists an open interval containing a such that f of a is less than f of x. So what I want to show you is a very similar graph. There we go. Okay, this goes up forever, this goes down forever. Now I'm going to go ahead and show you this is your relative minimum. Okay, now again, what this is saying is there an open interval? And we could pick, say, from here to here. Let's just take a look at that on the graph. If I highlight that, we're talking about from this area to this area. Okay, now, would you say that in this open interval that this y value right here, for that would be a, and this would be f of a, right here, is lower than any other y value in the blue area? It's like, sure. Well, that's what we mean by a relative minimum. Now, it's not the lowest on the graph, because over here on the right, this goes down forever. Okay, there is no lowest on the graph. But it is a low point within this open interval. And I would like to tell you that that's just basically, valley has an E in it, doesn't it? That's just basically a valley. Again, as a hiker, a valley is something you can hike down and back up the other side. If you hike down, like over here on the far right, you can't hike back up the other side. There is no other side. It would just be hiking down forever. So that is not a relative minimum. A relative minimum, you can hike down and back up the other side. No matter how treacherous it is, it's something that can be done. Okay? All right, here we go again. I've got a big graph over here for you on the right, and I ask a ton of questions about this. So domain and range came from the previous section. So if you're having problems with that, please go back and watch previous videos from just the functions videos. Increasing, decreasing, and constant, which are questions B, C, and D, we just learned how to do in this video. And then finally, the new guys, relative maximum points and relative minimum points. Let's take a look at that. So domain is left to right. So from the far left all the way to the far right, in other words, x values, what x values do we use to create this graph? Now, a lot of people would say, well, it looks like it's between -5 and 5, or but even between -2 and 2. Well, y'all, up here, this goes up and to the left forever. I know it looks like it goes up faster than it goes to the left, and it does, but it still goes to the left forever in this direction, and then also up and to the right forever in the positive x direction. So the domain, even though it looks a little odd, is -infinity to infinity. Every x value is covered in this graph because this goes up and to the left forever and up and to the right forever. Range is low to high. That may be easier to see. The graph does not go below whatever this y value is right here. Okay, so that y value happens to be -7. It is included, so I do -7. How high does the graph go? Now, I think that's pretty easy to see. It goes up to positive infinity. Okay, next question, intervals of increasing. This is where we might want to write right on top of our graph. Remember, increasing means it's rising from left to right. So you see this little piece down at the bottom? That part, I don't even have room to write increasing, is increasing. And then this piece right over here is also increasing. So there's two different intervals our graph is increasing. On the other hand, there are two different intervals our graph is decreasing. This long piece to the left is decreasing, and this little tiny piece down here is also decreasing. Now, to answer this question, it may help to have these points labeled, okay, and this point labeled so we know exactly where we're talking about. Well, this point here looks like the point -1, -7. This point on the far right over here looks like +1, -7. And then up above here looks like, I'm going to do this in a different color so we can see it a little better, 0, -6. Okay, now keep in mind, when you answer questions about increasing, decreasing, constant, you must use x values only. So all three of these are x values only. Okay, so increasing, let's do that. There's this little piece right here. The x value it begins at is -1, and the x value it ends at is 0. So that little hump right there. Okay, union, so that U without the little tail on it, that means union, which means combine two sets or intervals together. So we're combining that interval with the long piece on the far right that begins at x equals 1 and it ends at positive infinity. Okay, it doesn't stop up there where the arrow is. It continues up forever, and that's as we go to the right. Now decreasing, I have written over here in red the long piece first that begins at negative infinity. Okay, x value, not y value. Okay, x value way out here to the left. It is decreasing from negative infinity all the way to -1, union, and then the short piece begins decreasing at 0 and it stops at 1. Now remember we talked for increasing, decreasing, and constant. It is really best to put parentheses, at least in my argument, is that endpoints can't be included because the definition doesn't make sense at an endpoint. You would also be saying that it's increasing and decreasing at the same place, which is absolutely impossible. Intervals of constant. Notice that there's nowhere that this thing is completely horizontal. Don't leave it blank. Answer the question. You could put not applicable, you could put none, you could put does not exist, I like none, or nowhere, but make sure you address it. Okay, now here we go. Relative maximums and relative minimums. Now I'm going to take just a second to erase all the scribble that I have over here. If you need to see that, of course, just rewind again. But I want to have room to discuss relative maximums and relative minimums. Okay, now if you think about overall maximum, that goes up forever, right? And it goes up forever, but that's not what we're talking about. A maximum is a mountain, big mountain, little hill that you could hike up and over. Notice right in the center of our graph at this point right here that I'm labeling 0, -4, we have a little mountain. Okay, so that is the maximum point, 0, -4. We don't have any other mountains we could hike up and over. Okay, so that's it for maximums. Minimums, there's 2 of them. Okay, I'm going to label these in red. So right here and right here. Both of those are valleys. You could hike down in the valley and hike up the other side. So you can hike down in the valley and up the other side on both. And so if I label those points, okay, that one to the left is -1, -7. And we had already labeled it earlier. And, okay, you could put a comma, you could put an and. It's not a union because you're just talking about a point. But this point on the right here is 1, -7. Now it might come to this point where we're thinking, look, intervals look a whole lot like points, and they do. And to me that's kind of a bad thought about defining intervals and points. Is in the end they look alike, but it's in context. You know as a student after studying this, I know as an instructor, the increasing, decreasing, constant, it's not, those are not points you're talking about. You're talking about between values. So that's always intervals. On the other hand, when I ask for relative maximum points and relative minimum points, these are point answers. So we're not talking about all the numbers between 0 and -4. I'm literally talking about the x value 0 and the y value -4. Now there's another way to answer the question maximum and minimum as well. I asked it in terms of points right here, but also you could say as a y value. So in the book, if it asks for the maximum, you could just say -4. Here, if it asks for the minimum, you could just say -7. You don't have to write it twice because it happens to be the same both times. But it's possible to have 2 different y values. If the graph was not symmetric, you'd have 2 different y values, and you would just list them both. Okay.